Here are your notes on weak acids and strong acids, and remember they dissociate or ionize very differently. A weak acid only ionizes partially, and a strong acid will ionize completely. So here's a generic reaction. Hydrogen plus the anion for the acid in water will make H3O plus A minus, but we usually write it more simply. HA yields H plus A minus. Okay, and when they go into solution for a strong acid, since it ionizes completely, I can find the molarity just by the molarity I put in. So if I put in 3 molar HCl, I just broke it down in moles and we can assume that's 1 liter. I have 3 molar H plus, so that's my H plus concentration, and then I can use that to find the pH. I also have 3 molar Cl minus. Okay, so that strong acid is not going to be in equilibrium. Notice the sign doesn't change. We have complete ionization, complete transfer of that H plus. There is no equilibrium. Or weak acids are very different. They're in equilibrium, okay, which means I can write an equilibrium constant for that acid, which is products over reactants. Okay, and so that's my Ka. So then, if I know what this equilibrium is, I can use an ice chart to find my hydrogen concentration. I can change that into pH. So here's just the generic, in the generic format with my Ka, H plus A minus over HA. For bases, I have the same thing. I have weak bases and strong bases. These ionize completely and these do not. So here's 2 ways of writing it, one with H2O in it, one without. And then we can use this concentration for my strong base, because it ionizes completely, to find the POH, right? And then you can convert it into pH. Or I can go concentration of OH, concentration of H. You can go around that pH box any way you want. Again, it's not in equilibrium. Na breaks down to Na plus OH minus. No equilibrium. It ionizes completely, so there's no equilibrium expression. If I have a weak base, it is in equilibrium. So I have a Kb, which is the equilibrium expression for that base. And here's my generic format. Okay.